Hello students, this is grade 10 physics class. Chapter 10 light reflection and refraction completed, everything completed. So in this session we will start our 11th chapter, that is the human eye and the colorful world. What is that? The human eye and the colorful world. Actually in this chapter a few topics are deleted. Okay, so few topics are deleted. So due to coronavirus pandemic situation, the CBSE board has been deleted a few topics. Is it clear? Yes, I'll say what are the topics are deleted. Okay, so take a NCERT book, page number 187. What is that? Page number 187 in your NCERT book. Okay, yes. So the first topic is, what is the title? Chapter 11, the human eye and the colorful world. Okay. The first topic, that is 11.1, the human eye. That part, deleted part. Okay. The human 11.1, human eye and functions of human eye, then working process of human eye is deleted. Okay. Then turn the next page, page number 188, 11.1.1, the power of accommodation. That topic also deleted part. Okay, you leave it that. Next, come to page number 189, defects of vision under correction. That topic also is a deleted part. You avoid that. Next, turn next page, that is page number 190. Then these are the defects of vision under correction. The heterometropia and presbyopia. Okay, so both are deleted portion. Okay, yes. So the portion starts from 11.3, refraction of light through a glass prism. What is that? The portion starts from 11.3, refraction of a light through a glass prism. Is it clear? Yes. So then before topics are deleted topics, you no need to read that, you avoid. Okay, as per NCERT rule, NCERT norms, that is. Okay? Yes. So today we will start the topic, what is that? The refraction of light through a prism, through a glass prism. Is it clear? Yes. So page number 199. Okay. Is there any doubt? Okay. So today we will start next chapter. Actually that is chapter number 11. The human eye and the colorful world. The chapter name is the human eye. But most of the topics are deleted portions in the topic of human eye. Is it clear? Yes. Next we will see the colorful world. Okay. Yes. So in this chapter 11, first we will start the refraction of light through a glass prism. What is that? Refraction of light through a glass prism. Okay. I'll write the title. You look at here. So I'll write the title because I need some space. So today's class starts with a refraction of light through a glass prism. So refraction of light through a prism or glass prism. We can say that. Yes. What is the first topic in this lesson of chapter 11, first one, the refraction of light through a glass prism. Am I right? Yes. So already we have studied the refraction of light through a rectangular glass prism. What is that? Rectangular glass prism. Glass slab, not a prism, glass slab. Is that clear? Yes. But in this chapter 11, we will start with a new topic, that is refraction of light through a glass prism. That is rectangular slab, glass slab. This is glass prism. Is it clear? Yes. So in order to start this refraction of light through a glass prism, we must recall what is the refraction of light through a rectangular glass slab. What is that? Rectangular glass slab. Is it clear? Yes. So in the rectangular glass slab, the incident ray and emergent ray parallel to each other. Am I right? Incident ray and emergent ray both are parallel to each other. Am I right? Yes. Why? Because in the rectangular glass slab, the two refracting surfaces are parallel to each other, due to which emergent ray is parallel to the incident ray. Am I right? Yes. I'll draw the diagram. So you look at here. This is, what is this? This is rectangular glass prism. Glass slab. This is rectangular glass slab. Okay, yes. Glass slab. Is it clear? Yes. So this is one of the refractive surface. Consider name A, B, C, D. So AB is one of the refractive surface of the glass slab, and CD also one of the refractive surface of the glass slab. Is it clear? Yes. Here AB is parallel to CD, as well as CD is parallel to AB. So both refractive surfaces parallel to each other, due to which the emergent ray is parallel to the incident ray. Already we have seen that. Is it clear? Yes. So consider ray of light which falls on the surface of the glass slab, rectangular glass slab. Yes, this point, and draw normal. Here, light goes from rather than different medium, which means air into glass medium, due to which it will bend towards the normal, like this. Towards the normal. So this is refracted ray. This is refracted ray. Is it clear? Yes. So this is point of incidence. Point of incidence of second surface CD. Am I right? Yes. Draw normal line along with this point of incidence here. Here light goes from article denser medium to narrow medium, which means glass into what will happen? It will move away from the normal like this. Away from the normal like this. What is this? This is emergent ray. This is emergent ray. Am I right? Yes. So this is incident ray. This is incident. This is incident ray. Is it clear? This is original path of the incident ray. Okay, so if we extend this incident ray, what will happen? Then it will become straight line like this. It will become straight line like this. So this is original. Look at here. So this is original path of our incident light. Due to this presence of rectangular glass slab, this incident ray deviates from its original path, that is emergent ray. Am I right? Yes. So here this emergent ray and this original path of incident ray both are, what is it, parallel to each other? Can you see clearly? Yes. So this light, actually this is original path of a light, incident light, which is parallel to emergent ray, as well as the emergent ray is parallel to the incident ray, which means original path of the incident ray. So here, the emergent ray and the incident ray both are parallel to each other. Why? Because, look at here this refractive surface of the glass slab AB, which is parallel to CD. Am I right? Here, the both refracting faces are parallel to each other, due to which here this emergent ray is parallel to the incident ray. Is it clear? Emergent ray is parallel to the incident ray. But in this session we are going to see, refraction of light through a glass prism. What is that? Glass prism. Is it clear? Yes. See, this glass prism faces are not parallel to each other. Not parallel to each other like the rectangular glass slab. There is some angle between the two opposite faces. Okay, in this situation what will happen? That is the refraction of light through a glass prism. Is that clear? Yes. Okay, so in order to start that refraction process, you need to learn, you need to know some basic things about the glass prism. Is it clear? Glass prism. I'll draw that glass prism diagram. You look at here. Okay? Yes. I'll draw here. Yes. So this is a glass prism. The original diagram of glass prism. Is it clear? Original diagram of glass prism, that is. Okay, actually this is the original diagram. Okay, is it clear? Yes. So this is a glass prism diagram. Okay, so in this session we will discuss the refraction of light through a transparent medium transparent medium like what is it? Glass prism. Is it clear? Glass prism. Okay, is it clear? It's very, very simple. Look at here. So this is the actual diagram of the glass prism. Okay. So this glass prism has two triangular end and three rectangular lateral surfaces. Is it clear? Look at here. This glass prism has two triangular ends. Triangular ends are bases. We can say ends are bases. Then three rectangular lateral surfaces. Look at here. So this is actual diagram of the glass slab. Is it clear? Sorry, what is that? A glass prism, not a glass slab. I'm confusing. Okay, that is a glass prism. Is it clear? Yes. So this glass prism has two triangular base, or we can say triangular end. Okay. Then three rectangular lateral surfaces. Look at here. So this is one triangular end. Okay. I'll change the chalk piece color. Listen. So this is triangular base or end. This is first triangular base, or we can say that is end. Okay. Then this is another one. Triangular base or end, we can say that. Okay. So this rectangular glass prism, this triangular, confuse me. Okay, this triangular glass prism has two triangular bases and three rectangular lateral surfaces. Am I right? Yes, already we know that. So this is first one is a triangular base, and this is second one triangular base. Okay, then what is that? Next one is three rectangular lateral surfaces. Look at here. This is one rectangular lateral surface. This is rectangular lateral surface because that face is located sideways. Sideways, that is the reason why it is called lateral surfaces. Okay. Then this one, this part, this is also one of the rectangular lateral surface. This first rectangular lateral surface, and this is second rectangular lateral surface. Okay. Then this is third one. Look at here. This is third rectangular lateral surface. Is it clear? It's very, very simple. So in this session we will discuss the refraction of light through a glass prism whose refracting surfaces are not parallel to each other. Okay, that is glass prism. Okay, that transparent medium is a glass prism. Is it clear? Yes. This is the actual diagram of the glass prism. This glass prism has two triangular bases, or we can say triangular end. This is one triangular base, and this is second triangular base. Is it clear? Next, this glass prism has three rectangular lateral surfaces. Is it clear? Yes. So this one, the first rectangular lateral surface, and this one, second rectangular lateral surface, and this is third one rectangular lateral surface. Why that is called lateral surface? You may ask me. Because the opposite sides are placed lateral to each other, which means sideways to each other. They are placed sideways. That is the reason why that is called lateral surfaces. Is it clear? Yes. I have a glass prism. This is glass prism. Can you see clearly? Yes. This is glass prism. Actual diagram of glass prism. This is glass prism. Okay. Yes. So this glass prism has totally two triangular end and three rectangular lateral spaces, or we can say lateral surfaces, both the same. Okay. Yes. Look at here. This is one triangular end or base. Okay. So look at it. Can you see clearly? Yes. So this is one triangular base. Is it clear? Yes. Next one, this is one triangular base, and next one this is one triangular base. Is it clear? This looks like triangle. Okay. Yes. Next one, this glass prism has already we know what is the three rectangular lateral surfaces. Am I right? Yes. Look at here. This is one lateral surface, rectangular lateral surface. Can you see clearly? Rectangular lateral surface. This is one rectangular lateral surface, and this is second rectangular lateral surface, and this is third rectangular lateral surface. Is it clear? Very, very easy. Okay. Yes. So this glass prism has two two triangular bases. This is one triangular base and this is second triangular base, and three rectangular lateral surfaces. Am I right? So this is one rectangular lateral surface and second rectangular lateral surface and third rectangular lateral surface. Is that clear? Yes, very very simple. Okay, yes. Here these rectangular surfaces are not parallel to each other. Am I right? Look at here, this is not parallel. Actually this is inclined at an angle. Is it clear? The two surfaces placed inclined at an angle. Look at here, so this is not parallel to each other and this is not parallel to each other. Okay, but this triangular bases parallel to each other, but the rectangular lateral surfaces are not parallel to each other. Is it clear? That is very very important concept. Keep that in your mind. Okay, here the rectangular lateral surfaces are not parallel to each other. Keep this concept in your mind. But in glass slab, here this surface parallel to this surface and this surface parallel to that surface. But in glass prism, here the lateral surfaces are not parallel to each other. They are inclined at an angle between each other, between them. Is it clear? Yes, very easy one, don't get confused. Okay, yes. So that's all about prism. What is prism? Prism is made up of glass. That is the reason it is called glass prism. Then it has two triangular bases and three rectangular lateral surfaces. Here the three rectangular lateral surfaces are not parallel to each other. Okay, there is some angle between them. Is it clear? Yes, that is a concept. Keep this concept in your mind. Okay, yes. So this glass prism, this triangular glass prism is sometimes called glass prism. Okay, even sometimes called just a prism. Okay, so both they all are same meaning. So we can say triangular glass prism as well as glass prism as well as just a prism. Okay, so all are same meaning. You never confuse. Okay, what is that? How can we say that? Triangular glass prism one, or otherwise we can say glass prism, or otherwise we can say just a prism. That's all. Okay, yes, all are same meaning. Okay, yes. So here this triangular glass prism has three lateral surfaces. Is that clear? Three lateral surfaces. But in this session we are going to take just two lateral surfaces which is act as a refracting surfaces. This act as a refracting surfaces. Is it clear? Yes, look at here. So this is glass prism. This side and this side going to act a refraction. So we are going to access the refraction surfaces. Okay, which means refraction going to take place only the lateral surfaces. Look at this, very very important. Refraction going to take place only the lateral surfaces of the glass prism. What is the lateral surface? Which means the rectangular lateral surfaces of the glass prism, not in end. Okay, it's not in bases, which means these triangular bases. Only the refraction going to take place here, rectangular lateral surfaces. Is it clear? Yes, very simple. Actually, this is the actual diagram of the glass prism, but the sake of convenience in ray diagrams, most of the cases we will take this is glass prism. Most of the cases we will take that is glass prism, that is for our convenience. Okay, so in ray diagrams. Is it clear? Because the glass prism is a three-dimensional space. Is it clear? That is three-dimensional space, so we cannot draw clearly. Okay, yes. So that is the reason why. So in ray diagrams, okay, so in ray diagrams, especially refraction of light through a glass prism, we will take this diagram. So this is act as a what is a prism, glass prism. Is it clear? Very very simple. Okay, we don't need this diagram because that is complicated one. That is three-dimensional space. That is two-dimensional space. Okay, yes, very simple. So that's all about what is that? That's all about the triangular glass prism. Okay, consider a triangular glass prism. Consider a triangular glass prism. Yes, this is a glass prism. Yes. What is this? This is a glass prism. Generally, we say that is prism. Is it clear? Yes. Look at here. So mention the name of the faces of the glass prism. Consider this is P, then this is Q, and this is R. Is it clear? So PQ is a, what is this? Refractive. Okay, refractive phases. Next, P are also one of the refracting phase, and Q are also one of the refracting phase. Okay, which means the face of the triangular glass prism. Okay, this is where, so PQ is one of the space. Okay, which means the lateral space of the glass prism, and P are also one of the lateral face of the glass prism. Next, Q are one of the lateral face of the glass prism. Is it clear? Glass prism. Is it clear? Yes. Here, refraction going to take place only at the face of the glass, not only, sir, twice at PQ and QR. Okay, look at here. Refraction going to take place the face of the lateral surface of glass prism, PQ and PR, not in QR. Okay, not in QR. Only PQ and PR. That's all. Is that clear? It's very simple. So consider a triangular glass prism. This is a triangular glass prism. Okay. Then faces of the triangular glass prisms are PQ, PR. Is it clear? Then QR. But here the refraction going to take place at the surface of PR, and PR and the PQ. That's all. Okay? Yes. So this is a glass prism. Consider a ray of light. Consider a ray of light like this. Yes. Consider a ray of light. What is this? This is a ray of light. This ray of light falls. This ray of light falls on the surface of the triangular glass prism PQ. Where surface of the triangular glass prism PQ. Is it clear? Actually, what is this ray? This is incident ray. This is incident ray. Am I right? First, consider a ray of light. The ray of light falls on the surface of the glass prism PQ. Where? PQ. Here. Is it clear? Yes. So consider the name A. This is B. A and B. Is it clear? Yes. Look at here. Alright. This is incident ray. It is incident ray. So here AB is an incident ray. Okay, AB is an incident ray. So the ray of light falls on the surface of the, which means the lateral surface of the glass prism PQ. PQ is it clear? At this point. What is this point? This point is a point of incidence. Alright, this point is a point of incidence. Is it clear? Yes. Look at here. Next, draw a normal along with this point of incidence. Draw a normal along with this point of incidence. What is normal? Already we know the perpendicular line. The perpendicular line to the surface of the glass prism, that is normal line. Alright, that is normal line. Is it clear? Yes. Here the surface, the lateral surface of the glass prism is like this. Like this. Alright. Here, so what will be the normal? Normal should be like this. Which means perpendicular to that surface. Alright, like this. That should be perpendicular. Alright, yes. So draw a normal line along with this point of incidence like this. This is normal line. This is normal line. So look at that. That is right angle triangle. Alright, can you see this? That is right angle triangle. So this is normal 90 degrees. So consider normal n dash. Normal n dash. Is it clear? So this is normal. This is n dash. Okay? Yes, look at here. Next, so this ray of light falls on the surface of the glass prism PQ. Next, what will happen? Actually, next what will happen? Here light goes from air medium to glass medium because air surrounds the glass prism. So here light goes from air medium into glass medium. So air is one of the rarer medium, optically rarer medium, and glass is the optically denser medium. So whenever light goes from optically rarer medium to denser medium, what will happen? The refracted ray will move towards the normal. Am I right? Back towards the normal. So this is normal. Am I right? So this line is a normal. N dash is a normal. Okay, this point what is it? This is point B. This point B. So N dash is normal. So here, after refraction, the refracted ray move towards the normal. Look at here. this refracted ray move towards the normal like this. Is it clear? Yes, very simple. Okay. So look at here, this is refracted ray. This is refracted ray. This refracted ray falls inside. So inside of the second phase of the glass prism. Am I right? So this is second phase of the glass prism, PR. Here this refracted ray falls second phase of the incident, second phase of the surface of the glass prism here. Consider that point is C. This point is C. Am I right? Yes. Here it is a point of incidence. It is a point of incidence of second phase of a glass prism PR. Am I right? This is second phase. This is second surface of the glass prism PR. This is first surface and this is second surface. Okay. Yes. Here the refracted ray falls on the second surface of the glass prism here at point C. So point C is the point of incidence. Am I right? Yes. So here at the point C, draw a normal line. Okay. So look at here. So along with the point C, draw normal line. What is normal line here? Normal line is a perpendicular line to the surface of the glass prism. Actually, the surface of the glass prism like this. Surface of the glass prism, second phase of the glass prism like this. Okay, what will be the perpendicular line? The perpendicular line like this. That should be straight. Am I right? That should be perpendicular line. That should be a perpendicular line like this. Am I right? Yes. Here. So draw a normal line. Draw normal lines along with this point. Okay, yes, like this. Yes, that is normal. Can you see clearly? Yes. So this point C. So there is right angle triangle. Am I right? There is right angle triangle. Is it clear? Very simple. Don't get confusion. Okay? Yes. So this refracted ray. So here BC is a refracted ray. BC is a refracted ray. Is it clear? Yes. So this refracted ray falls inside the second surface of the glass prism at point here. What is the next move? Here, this refracted ray has to come out. Because air around the glass prism, because air also one of the transparent medium due to which this refracted ray has to travel in air. Am I right? Yes. Here light goes from glass medium to air medium. Am I right? Glass medium to air medium, because air around it. So glass is the denser medium and air is a rarer medium. So here light goes from optically denser medium into rarer medium. Am I right? Yes. So whenever light goes from optically denser medium to rarer medium, what will happen? The refracted ray will move away from the normal. Where? Away from the normal. Is it clear? Yes. So this is normal. Answer this is M dash. M dash. The first normal N dash. Second normal M dash. Okay. So this is normal. So here light goes from optically denser medium to rarer medium, due to which the refracted ray will move away from the normal like this. Away from the normal. Can you see clearly? Yes. So normal is here. This refracted ray moves away from the normal. Yes. Angle is more here. Am I right? Yes. So what is this ray? Actually, so what is that ray? That ray is called emergent ray. What is that ray? Emergent ray. That ray is called emergent ray. Is there any doubt? Very easy one. Don't get confused. Okay? Yes. Look at here. Here, this is incident ray. This incident ray and normal which make an angle. What is that? Angle of incidence. Angle of incidence denoted by letter I. This is angle of incidence. Is it clear? Yes. Next one, look at here. So this is refracted ray and this normal. So this angle between the refracted ray and the normal is called, what is that? Angle of refraction. I mean angle of refraction. So angle of refraction is denoted by letter here R1. R1. What is that? R1. Is it clear? Yes. Look at here. Here in second phase of the glass prism, so there is an angle between the normal and the incident ray. Actually, this refracted ray BC is a incident ray for the second phase of PR. Look at here, it's very important. This refracted ray BC is a incident ray incident ray for the second phase of the glass prism PR, because the refracted ray falls on the second surface of the glass prism PR. So that is considered as a, what is that? That is considered as an incident ray for the second prism PR, second phase of the second surface of the glass prism PR. Is it clear? So this is point of incidence. This is point of, sorry, what is that? This is angle of incidence for the second phase of the glass prism PR. Is it clear? So this is point of, what is the angle of incidence? 2. R2. It is considered as R2. Okay, so the angle between normal and the second surface of the glass prism PR, that is called, what is that? Second surface of this second surface incident ray, that is called, what is the angle of incidence. Is it clear? Yes. Look at here, very important term is here. This angle between the normal and the emergent ray, what is that? That is angle of emergent. Alright, angle of emergence is denoted by letter E. Angle of emergent. Is it clear? It's very simple. Okay, if you not clearly, you just pause your video and zoom in. Okay, is it clear? Yes. Is there any doubt? No doubt. Look at here. I'll repeat it. Consider glass prism. The phase of the glass prism PQR. PQR. Is it clear? Yes. Next, consider ray of light. A ray of light falls on the surface of the glass prism PR. Here at the point B. Is it clear? At the point B. So AB is an incident ray. AB is an incident ray. Then draw normal along with the point of incidence like this. So this normal and the incident ray make an angle. What is that angle of incidence? Denoted by letter I. Next one, look at here. This incident ray has to travel into glass medium. Is it clear? Because glass is one of the transparent medium. So here light goes from optically rare medium to denser medium. So whenever light goes from optically rare medium to denser medium, this refractor will move towards the normal. So this is normal light. This refractor will move towards the normal like this. Is it clear? Yes. This refractor ray falls on the second surface. Look at here, second surface of the glass prism PR here. Okay. Actually this refractor ray BC is an incident ray for second surface of the glass prism, because that light is falls on the second surface PR. Is it clear? Yes. Next one, draw a normal along with this point of incidence of second surface. So this is M dash is a normal. Am I right? Yes. Here this refractor ray has to come outside, because air around it are also one of the transparent medium. Is it clear? So this is normal. Then whenever light goes from optically denser medium, which is glass into air, rare medium, the refractor ray will move away from the normal. So this is normal, this move away from the normal. That ray is called the emergent ray. What ray? That ray is called the emergent ray. Is it clear? It's very simple. Next one, this normal and the emergent ray make some angle, that is angle of emergent. What is that angle of emergent? Very easy. You know the letter E, small e. Next one, there is some angle between here. There is some angle between the normal and the refracted ray, that is angle of refraction. Angle of refraction denoted by letter R1. Next, there is some angle between this refracted ray and this normal of second surface, that is called angle of incidence 2. Because already angle of incidence 1 is here, there is angle of incidence 2. That's all. Is there any doubt? So what is the point, sir? What is the point? Actually, look at here. Actually, this is original path of light. Due to presence of the glass slab, the light bends like this, and again light bends like this. Okay, first the original path of light this. Due to presence of this glass prism, light bends like this, and again light bends like this. Am I right? Suppose here the glass prism is not there. What will happen? If glass prism is not here, what will happen? Light path will be like this. Look at here. Light path will be like this. Yes. If glass, note this point very important. If glass prism is not here, the incident ray light path will be like this. It will be straight line. Am I right? So it will be AE. A is the original path of a light ray. What is it? This is original path of a light ray. It is the original path of the light ray, which is A is the original path of the light Is it clear? If glass prism is not here, AB will be the original path of a light, because light will travel in a straight line. Already we know that. Is it clear? Yes. So due to this presence of glass prism, light bends like this and other light bends like this. Is it clear? Yes. Look at here. This is emergent ray. Am I right? This is emergent ray. Is it clear? Very simple. This is emergent ray. Look at here. Okay, so extend this emergent ray backside. Extend this emergent ray backside. Look at here, like this. Yes. This is emergent ray. Yes, CD. Consider this CD. CD is a emergent ray. Extend this emergent ray backside. Backside. Look at here. Very important one. This original path of a light and the extension of this emergent ray meet at a point. Am I right? Look at here. Meet at a point here. Am I right? This point. That point consider as O. Look at here. This is O. This is O. Is it clear? Very simple. So this is original path of a light ray and extend this emergent ray backside. This extension of this emergent ray and the original path of a light meet at a point O. This is O. Is it clear? Yes. Very important. Next one. Listen here. So there is some angle. There is some angle between this original path of a light and the emergent ray, the extension of emergent ray. Am I right? There is some angle. Can you see clearly? Yes, this angle. This angle. That angle is called angle of deviation. This angle is called angle of deviation. That angle is called angle of deviation. Is it clear? The angle of deviation denoted with the letter capital D. Capital D. Is it clear? Yes. Look at here. So this is original path of a light. E is the original path of a light. Then look at here. This C, D. Look at here. The D and the O. It's a emergent ray. What is that? Emergent ray. There is some angle between the original path of a light and the emergent ray. That is called angle of deviation. Is it clear? That point is called angle of deviation. So here, come to the conclusion. So here, this emergent ray is not parallel to the incident ray. Am I right? Very important. This is emergent ray. This emergent ray is not parallel to the incident ray, because incident ray goes this direction, but the emergent ray moves towards downward direction, which means towards this direction. So there is some angle between this original path of a light and the emergent ray, that is angle of deviation. So here emergent ray moves away from the, look at here, moves away from the original path of a light. Can you see clearly? Okay, look at here. So there is some angle. I'll draw very large size. Look at here. Yes, there is some angle. This angle. So this is angle of deviation. Am I right? But in glass prism, come to here. In glass prism, this emergent ray, this is emergent ray. This emergent ray and the original path of the incident ray both are what is that? Parallel to each other. Can you see this? Parallel to each other. But in glass prism, okay, so due to the peculiar shape of the glass prism, here the emergent ray is not parallel to the incident ray. Here the emergent ray actually deviates. What is that? Emergent ray deviates from the original path of the incident light. Is it the original path of the incident light? That is the difference between the refraction of light through a glass prism and the refraction of light through a rectangular glass slab. Is it clear? Very simple. So here the emergent ray is not parallel to the original path of a light ray. But here the emergent ray and the original path of light ray both are parallel to each other. Why? Because here the refracting surfaces are parallel to each other, due to which emergent ray is parallel to this original path of light, which means incident ray. But here this refracting surface is over here. This refracting surface and this refracting surface is not parallel to each other. There is some angle. What is that? There is some angle between the two surfaces. That angle is called angle of prism. That angle is angle of prism. Look at here. This is what is that? Prism. This is prism. Consider this is P, Q, R. So PR is one of the face and QR is one of the face and QR is one of the face. Is it clear? Yes. So there is some angle. There is some angle between the two faces. Here also there is some angle between the two faces. Here also there is some angle between the two faces. Here each faces are not parallel to each other. There is some angle between them. That angle is called angle of prism. That is called, what is that? Angle of prism. Angle of prism. Look at here. So this is angle of prism. So this is one surface and this is one surface. Here there is some angle between these two surfaces. That is angle of prism. So here angle of prism. Here also angle of prism. Is it clear? Yes. So due to this peculiar shape of this glass prism, here the emergent ray is not parallel to the incident ray. Is it clear? But in a rectangular glass slab, here the two surfaces are parallel to each other, due to which emergent ray is parallel to incident ray. But here the two surfaces are not parallel to each other. There is some angle between them. That is angle of prism. Am I right? Yes. So due to this peculiar shape of the glass prism, emergent ray is not parallel to the incident ray. Actually, the emergent ray deviates. Note this point. Emergent rays deviates from the original path of a light ray. Is it clear? So that angle is called angle of deviation. Angle of deviation, very easy. Angle of deviation denoted by letter capital D. Is it clear? Very, very simple, don't get confusion. Okay, so try to understand my concept. Okay, yes. But this angle of incident is equal to angle of emergence. Alright, so the angle of incident D, it will be equal to angle of emergence. What is angle of incidence? The angle of incidence is divided the angle between the incident ray and the normal, that is angle of incidence. Then what is angle of emergence? The angle between the emergent ray and the normal, this is angle of emergence. Is it clear? Here the angle of incidence will be equal to angle of emergence. Why sir? You may ask me why sir? Because look at here. Here the incident ray travels in what medium? R medium. Okay, incident ray travels in what medium? R medium. What is the speed of light in R medium? 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second. That is speed of light in R medium. Am I right? Yes. Look at here. Here the emergent ray. Emergent ray travels in the same R medium. Am I right? Emergent ray also travels in same R medium. What is the speed of light in R medium? The same 3 into 10 to the power of 8 meters per second. So look at here. Here the incident ray and the emergent ray both are travels in the same medium of R, due to which the two rays speed same. Am I right? Two rays speed same. So it make the same angle. It make same angle. Is it clear? It's very easy. So this angle of incidence is equal to angle of emergence. Not angle of deviation, angle of emergence. Is it clear? Because both rays speed same. Both rays are travels in the same medium, that is R medium. Okay? Yes. So that is a conclusion. That is a conclusion of refraction through a glass prism. That's all. Very easy. Is there any doubt? No doubt. So here AB is a, what is that? AB is a incident ray. Now incident ray. Then BC is a refracted ray. BC is a refracted ray and CD is a emergent ray. Emergent ray. Then what is that? Then A is the original path of the ray. Already we know that very well. Then what is that? I is the angle of incidence. Remaining right here. I is the angle of incidence. I is angle of incidence. Then R1 is the angle of refraction. Angle of refraction. And this R2 angle R2 is the angle of incidence for second phase. Angle of incidence of second surface. Angle of incidence of second surface of the glass prism PR. Alright. Then E angle is the angle of emergence. Yes, that's a very easy one. This is very important 5-mark question. It's not a 5-mark question, that is a 3-mark question. It's very important 3-mark question. Is it clear? It's not a 5-mark question, it's worth to 3-mark question. Okay? Very simple. Is there any doubt? Is there any doubt? No doubt. Okay? First, consider glass prism. Then ray of light falls on the glass prism, due to which light refract like this, and again light refract like this. Is it clear? So this is emergent ray, and if glass prism is not here, then AE will be the original path of a light ray. Am I right? So here the emergent ray moves away from the original ray. So original light ray goes like this direction, straight direction, but the emergent ray moves downward direction. So here the emergent ray moves away from the, okay, actually there is deviates from the original path of a light ray. Is it clear? Yes. So the angle between the original path of a light and the emergent ray is called angle of deviation. Note this point, very important. What is angle of deviation? The angle between the original path of a light ray and the emergent ray, which means the extension of emergent ray, that is called angle of deviation. Actually, here the emergent ray deviates from the original path of a light ray. Is it clear? Yes. But here the emergent ray deviates from the original path of light ray, so due to its peculiar shape. Okay, peculiar shape means nothing but it's not a parallel to each other. There is some angle between the two surfaces of the glass prism. That is the reason why. But in glass slab, here the two refracting sides are parallel to each other, due to which this emergent ray is parallel to the incident ray. But here the two surfaces are parallel to each other. There is some angle between them. What is that angle? That is angle of prism. Look at here, that is angle of prism. Is it clear? Yes. So this emergent ray deviates from the incident ray. That is a concept. Is there any doubt? Yes. That's all. Here, this angle of deviation. Look at here. This angle of deviation D depends on 3 factors. Depends on 3 factors. The angle of deviation depends on 3 factors. 3 factors. So what are the factors, sir? You may ask me, what are the factors, sir? First one, the angle of prism. First one, this angle of prism. First one, the angle of prism, and second one, nature of the prism. Nature of the prism. And third one, okay, and third one, the angle of incidence. Angle of incidence. Look at here. This angle of deviation depends on 3 factors. First one, the angle of prism, and second one, nature of the prism, and third one, angle of incidence. Look at here. So already we know there is some angle between the surfaces of the prism. Surfaces of the prism. Look at here. That is called the angle of prism. That is called angle of prism. Suppose if the angle is changes, what will happen? If the angle is changes, the angle of deviation also changes, which means the refracted light direction will change. So due to which this angle of deviation also changes. Is it clear? That is first factor. And second factor, what is the nature of the prism? Actually, generally the prism is made up of glass. Okay, glass. Okay, so already we know the refractive index of a glass. What is that? That is from 1.5 to 1.9. The refractive index of glass, what is it? 1.5 to 1.9. Is it clear? Suppose if the glass this prism refractive index is 1.5. Consider this prism refractive index 1.5. Suppose instead of that we make a glass prism. That glass prism refractive index is 1.9. So do you think this 1.9 glass prism will bend light same amount as that of 1.5 glass prism? No, that is not possible. Okay, it will bend the light more amount. So due to which the angle of deviation will change. Angle of deviation will change. We have different types of glass materials. If we change the glass materials, as corresponding, this angle of deviation also will change. Okay, yes, that is depend on the refractive index. And third one is the angle of incidence. So here in this case the angle is like this. Okay, suppose if we allow the light ray falls like this, what will happen? Which means if we change the angle of incidence, what will happen? The corresponding light direction will change as well as the emergent ray will change. So the angle of deviation also will change. Is it clear? Yes, that's all. So this angle of deviation depends on three factors. First one, what is that? The angle of prism. Second one, nature of prism. And third one, angle of incidence. That's all. So that's all about the refraction of light through a glass prism. Glass prism. That's all. Is there any doubt? No. You draw this diagram to your classwork note and mention the all parts in your classwork note. Is it clear? Yes. So what is the conclusion? What is the conclusion? Here in refraction of light through a glass slab, here the emergent ray will not be parallel to the incident ray. Look at here, will not be parallel to the incident ray. Why? Because here the two refracting surfaces are not parallel to each other. There is some angle between them. That is called, what is that? Angle of prism. Is that clear? Yes. But in rectangular glass prism, here two refracting surfaces are parallel to each other, due to which the emergent ray will parallel to the incident ray. Is that clear? Yes. That is a conclusion. Very easy one. Okay? Yes. So next we will see the dispersion of light. What is that? Next one, dispersion of light. Is it clear? Yes. So before starting that, I am going to ask few questions. Okay. So what is the color of this board? That board color is green color. Am I right? Yes. So what is the color of my shirt? It may be pink color. Am I right? Yes. So what is the color of this book? Yes, it may be yellow color. Am I right? Yes. Next, I will ask very important question. What is the color of the sunlight? What is the color of the sunlight? The sunlight, okay, if I ask this question, most of us we will say the sunlight color is yellow color or red color or orange color or no color and so many things. Am I right? Actually, what color is it? Actually, what color? Actually, the sunlight color is white color. What is that? Sunlight color is a white color. Do you think that is possible? Yes, of course, sunlight color is white color. But that white light consists of a mixture of 7 colors. How many colors? The white lights consist of a mixture of 7 colors. So what are the colors, sir? What are the colors, sir? First one, red, orange, yellow, green, blue, indigo, violet. That is called VIBGYOR colors. Already we know very well. Am I right? Yes, I'll write the colors one by one. The sunlight, okay, which means white light consists of 7 colors. First one, red color. Second one, orange. Third one, yellow. Fourth one, green. Fifth one, blue. Sixth one, indigo. Seventh one, violet. Generally we see what is that? VIBGYOR colors. VIBGYOR. That is, we say there is acronym. What is that? VIBGYOR colors. Already we know very well. Okay, so white light is a mixture of how many colors? 7 colors. So what are all the colors, sir? First one, red color, orange color, yellow, green, blue, indigo, and violet. Even sunlight also consists of a mixture of totally 7 colors. Is it clear? Yes. How can you prove, sir? Next question. How can we prove the sunlight consists of a mixture of 7 colors? Not only sun color, generally white light. White light consists of a mixture of 7 colors. Yes, we can prove by dispersion of light. What is that? We can prove white light is a mixture of 7 colors by the process of dispersion of light. What process? Dispersion of light. In the year of 1665, Sir Isaac Newton discovered by his experiment with glass prism white light is a mixture of 7 colors. What is that? White light is a mixture of constituent 7 colors. Is it clear? Is it clear? Yes. He found that if a beam of white light is passed through a glass prism, the glass prism splits the white light into 7 colors. Splits the white light into 7 colors. So that is called dispersion of light process. That process is called dispersion of light. Dispersion of light. Is it clear? It's very simple. We will see what is the dispersion of light next. Is it clear? Yes. So already we know the sunlight is a mixture of 7 colors. 7 colors. What are the colors, sir? Red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, and violet. Is it clear? Then why we cannot see all those colors in daytime? Am I right? That is a very big question. You may ask me, then why we cannot see all those colors during daytime? Because sunlight is here. Due to sunlight, we cannot see so many things around us. Then why we cannot see all those colors in daytime? Because sunlight is a mixture of 7 colors. Am I right? Yes. It's a very interesting question. I'll give this question answer later. Because it's a very important one. I'll give this question answer later. Is it clear? Yes. Very, very important one. Next, we will see what is that? Dispersion of light. Very important as well as interesting one. We will look at what happens. Okay? Yes. Next we will see what is that? Dispersion of light. Okay? Yes. Consider a glass prism. Okay, for this experiment we are going to take a glass prism. Okay? Consider a glass prism. Actually this experiment is found by Sir Isaac Newton. Yes. Consider a triangular glass prism. It is a triangular glass prism. Okay. Then the faces of the glass prisms are P, Q, R. So PQ is one of the surface. What surface? That is a rectangular lateral surface. And PR also one of the rectangular lateral surface. Even Q are also one of the rectangular lateral surface. Is it clear? But here the refraction going to take place only the faces of PQ and PR, not in QR. Okay? Yes. So consider that this is it's not a rectangular glass prism, sorry, it's a triangular glass prism. Sorry for that. I thought the rectangular glass prism. Sorry, glass slab. This is a triangular. This is a triangular glass prism. Sorry for that. Okay. Next, consider a white light, beam of white light. Okay, consider a beam of white light. This is beam of white light. Yes. So this is a beam of white light, not a ray of white light. It's a beam of white light. Okay. So this is a beam of white light. It is a beam of white light. Okay, consider a triangular glass prism. Yes. Then consider a beam of. This is a beam. That's why I have made into dark line. Okay, so it's a beam of white light. What is the beam of white light? Is it a white light? Nothing but it's a sunlight. Sunlight also white light. Okay. Consider beam of white light. The beam of white light falls on the surface of the glass prism PQ. Our surface of the glass prism PQ. Is it clear? Yes. Here light goes from air medium into glass medium, which means optically rarer medium to denser medium. Air is a denser rarer medium and glass prism is a denser medium. Am I right? Yes. Look at here. When the beam of white light falls on the surface of the glass prism, here the white light splits into 7 constituent colors. 7 constituent colors. Look at here like this. So when a beam of white light falls on the surface of the glass prism, white light splits into 7 constituent colors like this: 1, 2, 3, 4, 5, then 6, then 7. 7 constituent colors. Is it clear? Yes. Like this. First one, what is that, sir? First one, this is red, and second one orange, third one yellow, fourth one green, and fifth one blue, sixth one indigo, and seventh one, what is that? Violet. Look at here, what is the concept here? So when a beam of white light, notice fine, when a beam of white light falls on the surface of the glass prism PQ, here the white light splits into 7 constituent colors. The 7 constituent colors such as red, orange, yellow, green, blue, indigo, and violet. Is it clear? Yes. This white light split into 7 colors. 7 colors and passing through a glass prism is called dispersion of light. This is called dispersion of light. Very simple. Look at here. So when a beam of white light falls on the surface of a glass prism, here the white light splitting into 7 constituent colors, that is called dispersion of light. Very easy. So this is very important 3-mark question. Okay, I'll write here. You look at here. The splitting up of white light into 7 colors on passing through a glass prism. So that is called dispersion of light. So what is that? The splitting up of white light into 7 colors on passing through a glass prism, that is called dispersion of light. Very easy one. Okay, so when a white light falls on the surface of a glass prism, the white light splits into 7 colors, 7 constituent colors, or 7 mixture of white light. That is called dispersion of light. Is it clear? That phenomena is dispersion of light. Is it clear? Very, very important. Next question rising here. So why white light splits into 7 colors when it falls on the surface of the glass slab? Am I right? That is very big question. Why? Because look at here. Here the white light, already we know the white light is a mixture of 7 colors. White light is a mixture of 7 colors. Here before falling on the glass prism, here the white light travels in what medium? White light travels in air medium. Am I right? White light travels in air medium. So in air medium, the all colors speed same. The all constituent colors of white light speed same. Is it clear? What is the speed here in air medium? 3 into 10 to the power 8 meters per second. Okay, 3 to 8, 10 to the power 8 meters per second. That is the speed of white light in the medium of air. So here the different colors of white lights have same speed in air. Note this point. The different colors of white light have same speed in the medium of air medium. In the medium of air medium. Look at here. So these all 7 colors travels in same speed in air medium. Same speed in air medium. So then, but at the moment they hit on the surface of the glass prism, here the different color speed changes in glass prism. What is that? At the moment of the white light falls on the surface of the glass prism, different color speed changes in the glass prism, due to which the 7 colors splitting. Okay, 7 colors are splitting when it falls on the surface of the glass prism. Is it clear? So that is the reason why. So that is the reason why the white light is splitting into 7 colors. So what is the conclusion here? So when the white light travels in the air medium, the all constituent colors speed remains same. That is 3 to the power of 8 meters per second. But at the moment they hit in the surface of the glass prism, different colors speed changes. Okay, which means these all color speed changes. Is it clear? So that is the reason why white light splitting into 7 constituent colors. Is it clear? It's very simple. So look at here. The first one is, what is that? The first ray, that is red color, and second one orange color, third one yellow color, fourth one green color, and fifth one blue color, sixth one indigo color, and seventh one, last one, what is that? That is a violet color. Violet color. Is it clear? Yes. Here, the different colors refracted at different angle. Different colors refracted different angle. Am I right? Yes. Look at here. What is the refraction? Bending of light. So the red light bends less amount. Look at next one. The orange color bends more than yellow color bends more from here. Then the green color bends more. Then next one, last one, the blue bends more. Then last indigo color bends more compared than these all. Then last one, finally violet color bends more compared than remaining 6 colors. So here the red color bends less amount. Red color light bends less amount. Then violet color bends more amount. Is it clear? Why sir? Why red color bends less amount? Then here violet color bends more amount, because red color speed maximum, whereas violet color speed minimum. That is the reason why red color bends less amount, which means refracted less amount, than violet color refracted, which means bends more amount. Is it clear? Yes. So red color has maximum speed, then what is the orange color has minimum speed compared than R, then yellow color has minimum speed compared than R and O, then green color has minimum speed compared than Y, R, which means yellow, orange and red, and like this. It will go like this. Actually this is, what is that? So decreasing order. Okay, from the red it is a decreasing order. So that is the reason why white light splits into 7 constituent colors. Is it clear? Yes. Next, what will happen? These 7 constituent colors falls on the surface of the prism. Actually, the second surface of the glass prism. What is that? P R. Okay, here these 7 colors falls on the second surface of the glass prism P R. What is that? P R. Is it clear? Yes. What is the next move? They have to come out. Is it clear? They have to come out, which means they have to travel in air medium, because air around it. Is it clear? Yes. Next, place a white screen after the glass prism here. This is white screen. This is white screen. Okay, so place a white screen after this glass prism. Is it clear? Then what will happen after falling these 7 constituent colors of white light on the surface of the second glass prism? What will happen? These all refracted rays should come outside. Because around this are also part of the medium. So these all 7 colors falls on the white screen. Falls on the white screen like this. 1, 2, 3, 4, 5, 6, 7. So first one, what is that? This is red color. This is orange, yellow, green, blue, indigo. Then finally white. Finally that is violet. Is it clear? Yes. Here the 7 constituent colors of white light falls on the white screen. So on the white screen we can see the 7 constituent colors of white light. So that is called, what is that? That process is called dispersion of light. That process is called dispersion of white light. Very simple one. Is it clear? Yes. Here the band of 7 colors formed on the white screen when the white light is passed through this glass prism. That is called spectrum. What is that? Spectrum of light. Spectrum of white light or general light. Look at here the band of, okay, band means nothing but a combination. Okay. Here the band of 7 colors. What are the colors? Red, orange, yellow, green, blue, indigo, violet. So the band of 7 colors are found on the white screen when the white light passed through a glass prism is called spectrum of white light. What is that? Spectrum of white light. Spectrum means nothing but the 7 colors. The 7 constituent colors of white light, that is called spectrum of light. Is it clear? That is called spectrum of light, the very easy one. So this is white screen. So that's all about this dispersion of light. That's all about the dispersion of light. Is it clear? Yes. Next one, look at here. Suppose if glass prism is not here, if the glass prism is not here, so what will be the original path of a light ray? It will be the original path of light ray. It will be the original path of light ray. Am I right? Yes. I'll write that. I'll rub that definition because I need some space. Look at here. See, if glass prism is not there, it will be the original path of a light ray. Consider that is A, E. What is that? A, E. Okay, so if glass prism is not here, AB will be the original path of light ray. Alright, this is original path of the light ray. But these 7 constituent colors emerging out downward direction. Am I right? Emerging out downward direction like this direction. Am I right? Yes. So there is some angle between this original path of a light and the what is this? This refracted rays. Each rays are refracted rays. Already we know. Sorry, it is emergent ray because it's coming out from glass prism. The emergent ray. What is the angle? That is angle of deviation. Am I right? So look at here. This one. This angle of deviation. So the angle between the emergent ray and the original path of light ray, already we know that is angle of emergent. Am I right? Yes. Look at here. This angle of deviation. So this angle of deviation is less for the red light because red light is maximum speed. Red light has maximum speed. Then orange has minimum speed compared to red like this. Here, which light deviates more amount? Which light deviates more amount? White light. Look at here, the white light angle of deviation is more. Am I right? And which light angle of deviation is less? Here, the red light angle of deviation is less. Because red light has maximum speed, that is the reason why it deviates less amount from the original path of a light ray. Whereas in the white light has less speed. What is that? Less speed. That is the reason why it deviates more amount. Okay, maximum amount from the original path of a light ray. What is that? Original path of a light ray. Is it clear? So very very simple. So here the different light rays, different light rays deviates different amounts basis on their what basis? Based on the light of based on the speed. Based on the speed. Is it clear? It's very simple. That is called dispersion of light. Is there any doubt? No doubt. So what is the dispersion of light here? Dispersion of light here, the splitting up of white light into 7 constituent colors on passing of white light into the glass prism, that is called what is the dispersion of light. Okay, generally we say that is splitting up of white light into 7 colors, that is called dispersion of light. Next one, what is the spectrum of light? What is the spectrum of light? Here, the 7 colors are formed on the white screen when the white light goes through the glass prism, that is called spectrum of light. Is it clear? It's very simple. Here which light deviates maximum amount? Violet color deviates maximum amount, and which light deviates less amount? Here the red light deviates less amount because here the angle of deviation basis on the light speed inside the glass prism. Is it clear? So that's all about what is that? Dispersion of light. Okay, before a few minutes you ask one question, what is that? Why we cannot see the 7 colors, the constituent 7 colors of white light during daytime? Am I right? Why? Because here the white sunlight travels in only what medium? Air medium. So whenever light travels in only one medium, which means air medium, especially in air medium, the different colors have same speed. What speed? Same speed. That is the reason why we cannot see the 7 constant colors of white color during daytime. Is it clear? Yes. Different colors have same speed in air medium. That is the reason why we cannot see the different colors. Okay. Yes. So that is called different dispersion of light. Dispersion of light completed. Okay. Yes. Next one, recombination. recombination. The recombination of spectrum colors to give white light. To give white light. Recombination. The recombination of spectrum colors. Spectrum colors to give white light. To give white light. What is the next one? Recombination of spectrum colors to give white light. To give white light. So already we know. So when white light falls on the surface of the glass prism, the white light splits into 7 constituent colors. Am I right? Suppose if we place another prism after a first prism, what will happen? What will happen? This all refracted rays recombine and it will give again white light. It will give again white light. That process is called recombination of spectrum colors to give out white. Okay, which means the all spectrum colors recombine, again it produce white light. Again it gives out white light. That is called recombination of spectrum colors to give white light. Is it clear? Yes, we will see that. Okay. Yes. Consider prism. Consider glass prism. So this is prism 1. This is prism 1. Okay. Then phases of the glass prisms are P, Q, R. This is first prism. The phases of the glass prism are P, Q, R. Is it clear? Yes. Next one. Look at here. Consider a beam of white light. Consider a beam of white light. This is beam of white light. This is beam of white light. The beam of white light falls on the surface of the glass prism. Alright, next what will happen? So when the beam of white light falls on the surface of glass prism, the white light splits into 7 colors. Alright, like this. The white light, yes. The white light splits into 7 colors. Okay, first consider prism 1. The beam of white light falls on the surface of the glass prism PQ here. So when the white light falls on the surface of the glass prism, the white light splits into 7 constituent colors like this. Like this. Is it clear? Yes. Next, consider another prism. Consider another prism which is placed after the first prism, that is inverted position. What is that? Inverted position, which means reversed position like this. Reversed position like this. Can you see clearly? Yes. Okay, consider second prism. This is second prism. This is prism 2. Actually, the second prism is placed after the first prism, that is inverted position, which means reversed position. Is it clear? Yes. So here the faces of the second glass prisms are, this is P dash, same as that of P, this one. Then this is Q dash, same as that of this face. This is R dash, same as that of this R. Is it clear? Very easy. Is it clear? Yes. So there is some gap. There is some gap between the two glass prisms. Am I right? Yes. So this glass prism, this first glass prism splits the white light into 7 colors. The 7 colors falls on the second surface of the first prism. Okay, this is second surface of the first prism PQ here. What is the next move? There is a gap. Okay, there is air between both. Alright, there is air medium between the both glass prism. Alright, next what will happen? This refracted 7 colors should come out. Alright, yes. So next, the 7 colors. The 7 colors, look at here. Here the 7 spectrum colors. 7 spectrum colors falls on the second prism. This is second prism. Am I right? Second prism actually displays inverted position. Okay, inverted means reversed position. Okay, so this all 7 spectrum falls on the second prism. Okay, second prism which is placed inverted. Am I right? Next what will happen? Next what will happen? This second prism actually recombine the spectral lines. Recombine nothing but which focus the all light rays in the same place. Okay, like this. The second prism recombine. Yes, the second prism recombine. Look at here. The second prism recombine the all 7 colors. All 7 colors here. Okay. What is the next move? Here, the after recombine. Look at here. After recombine, the second prism changes the all spectral colors into white light. It becomes white light. It becomes white light. Very easy one. Is it clear? Very simple. I will repeat it again. Look at here. Consider the first prism PQR. Then consider a beam of white light. The beam of white light falls on the surface of the glass. The first glass prism PQ here. Is it clear? So due to dispersion, the white light splits into 7 different colors like this. 7 different colors like this. So the 7 different colors falls on the second surface of the first prism. This is first prism. The second surface of the first prism here. Alright. So next take a second prism. We place the second prism after the first prism. Actually, that is inverted position, which means reversed position like this. Reversed. Okay. This is the top of the first prism, and top is here in bottom of the second prism. Am I right? Yes. So P dash is the corresponding face of the first one here, and this one corresponding second one here, and this one corresponding face here. That is inverted position like this. Am I right? Yes. So this all the refracted 7 colors falls on the second prism. What is that? Second prism here. Am I right? Yes. This second prism is placed inverted. So the second prism recombine the 7 spectral colors here. Am I right? Yes. So as Aaron said, so due to recombine, the second prism produce, which means it gives out only white light. Actually, we are allowing white light, and second prism which gives out white light. Is it clear? So this process is called recombination of spectrum colors to give out white. You may ask me, so why, sir? Why the second spectrums recombine and gives out white light? So this is called recombine. This process is called recombine. Actually, the first prism produces the 7 spectral colors, and second prism receives the second spectral colors and gives out white light. Why, sir? Why the second prism gives out white light? Because the second prism plays inverted position. Am I right? Inverted position. That is the reason why the second prism gives out only white light. Look at here. So this side is equal to which side? PQ is equal to P dash Q dash. Am I right? P dash Q dash. Then this side is equal to this side. Is it clear? Yes. At the face of PQ, here white light splits here. So whereas here, look at this side, here the all light spectral lines converge at a single point, which means recombine at a single point. Is it clear? Then due to which second prism gives out white light. As well as there is other reason, then this safe parallel to this safe. Am I right? The surface of PQ, which is parallel to the surface of second prism P dash Q dash. Here the PQ and P dash R dash both are parallel to each other. So whenever the two surfaces are parallel to each other, this incident ray and the emergent ray will be parallel to each other. Am I right? Like this. Yes. If glass prism is not here, it will be the original path. So here, this original path of the light ray and this emergent ray, which means the white light, both are parallel to each other. Okay, so look at here, what is the concept here? So due to inverted position of the second prism, the second prism recombine the all spectral colors and gives out white light. That is a process. Actually, that is happens here. As well as this side and this side both are parallel to each other. So the incident ray and the white light parallel to each other. That's all. Actually, that's what happening here. Is it clear? It's very simple. So this lesson getting over. Next we will see next topic. Okay, thank you.